Why can't we predict the weather with total certainty? Even with satellites orbiting above us right now, watching every cloud form in real time, we have supercomputers that perform quadrillions of calculations every single second, crunching through more numbers than we could count in a lifetime. We have artificial intelligence, trained on decades and decades of historical weather patterns from every corner of the planet. And still, forecasters get it wrong, sometimes just days or even hours in advance. Imagine you want to predict tomorrow's weather with perfect, flawless accuracy. You have the most powerful computer on the entire planet sitting right in front of you. You have the best mathematical formulas ever devised by the greatest physicists in history. You have the most complete data set imaginable. Temperature, pressure, humidity, and wind measured everywhere on Earth. But one tiny, almost invisible error creeps quietly into your numbers, unnoticed by anyone. It's buried deep in the sixth decimal place, so small that no human being would ever think twice about it. And somehow, impossibly, it makes the entire forecast completely, utterly different from what it should have been. How is that even mathematically possible? This isn't a thought experiment, and it isn't science fiction. This actually happened in a real laboratory on a real machine, and it proved that the future is far stranger and far less predictable than anyone had ever dared to imagine. For centuries, the greatest scientific minds in history believed something remarkably simple and remarkably comforting. If you could somehow know the exact position and speed of every single particle in the universe, then, in principle, you could predict absolutely anything that would ever happen forever. The motion of every planet, moon, and comet, calculated centuries into the future with total precision. The weather, down to the smallest passing cloud on the most ordinary afternoon. The ocean currents, the tides, even the slow shifting of sand dunes across an entire desert. Even the future itself, they believed, was already written somewhere in the mathematics, just waiting to be uncovered. It was simply a matter of collecting enough information and building a machine fast enough to compute it all. Being fundamentally, catastrophically wrong about the future seemed to them almost impossible to imagine. The year was 1961. A meteorologist was running weather simulations on one of the very first computers ever built for this kind of scientific work. There were no weather satellites circling the Earth yet, not a single one. Just a room-sized machine, packed with vacuum tubes and tangled wires, humming away quietly in the background. By today's standards, it was almost unbelievably slow, thousands upon thousands of times slower than the phone sitting in your pocket right now. One ordinary afternoon, he wanted to rerun a simulation that he had already computed the day before. To save a little time, instead of starting the whole calculation completely from scratch, he decided not to type in every single decimal exactly as the machine had originally printed it out. Instead of entering 0.506127, exactly as it appeared on his printout, he simply typed 0.506, rounding the number off just slightly to save a few seconds of typing. The difference between those two numbers was microscopic, a rounding error smaller than 1,000th of a single percent. Mathematically, by every rule anyone understood at the time, it should have meant absolutely nothing at all. He started the machine running again and walked away to get a cup of coffee, expecting nothing unusual whatsoever. When he came back a couple of hours later, fresh printout in hand, he froze completely. The new simulation looked absolutely nothing like the one he had run the day before. Not slightly different, not a small deviation he could simply explain away and move on from. Completely, radically different, as if the machine were describing the weather on an entirely different planet. Where his first run had shown calm, quiet skies, this new one showed massive hurricanes tearing across the map. Entire storm systems appeared out of nowhere, systems that simply hadn't existed in the original run. The weather patterns were now completely unrecognizable, as if a totally different world had somehow been simulated. And all of this happened because of one single, tiny difference, buried far down in the decimals. A number that, to any human eye glancing at it, looked almost exactly, perfectly identical to the original. He had just stumbled onto something absolutely extraordinary, something no one had ever properly documented before. Some systems, he slowly began to realize, are so incredibly sensitive to their exact starting conditions that a tiny, imperceptible difference right at the very beginning can snowball over time into an enormous, completely unrecognizable difference at the end. At first, understandably, he assumed it had to be a bug, some glitch hiding somewhere inside his machine. But it wasn't a flaw in the computer at all. It was a fundamental property of nature itself. The man who made this discovery had a name, Edward Lawrence, and the strange phenomenon he had just uncovered would soon get a name of its own too, one that would echo far beyond meteorology forever: chaos theory. His discovery gave science one of its most iconic, most enduring ideas, one that everyone has heard of, even if they don't know where it came from. Could the simple flap of a single butterfly's wings, somewhere in Brazil, possibly set off a tornado all the way in Texas, weeks and weeks later? Of course, the butterfly itself doesn't literally cause the tornado, not directly, not on its own, but in extremely complex, deeply interconnected systems, like the atmosphere wrapped around our entire planet. A tiny, seemingly insignificant change can ripple outward and quietly alter absolutely everything that follows. This is exactly why we still can't accurately forecast the weather more than about 10 days ahead, no matter how advanced our technology becomes. This is why financial markets, driven by millions upon millions of interacting human decisions, are so notoriously difficult to predict or ever fully control. This is why a disease outbreak can suddenly spiral off in completely unexpected directions, defying even our very best epidemiological models. And it's exactly why even the most advanced artificial intelligence on Earth hits hard, fundamental limits when trying to predict complex, chaotic systems. It's not that the underlying mathematics is wrong, or that our models are somehow badly built. It's that reality itself is unbelievably, fundamentally sensitive to even the tiniest of changes, all the way down. Before Lawrence made his discovery, we thought of the future as a perfect machine, one that would eventually reveal every single one of its secrets to us. After Lawrence, we understood something far stranger, and in many ways, something far more humbling about the universe we live in. Sometimes, one single, simple decimal, rounded off almost without a second thought, can change absolutely everything we thought we understood about the world around us. If this made you see prediction and the future itself a little differently, subscribe for more stories where one small idea quietly changed absolutely everything. And like this video if you want more turning points exactly like this one. Turning point.